Hello everyone, this is the Bridge for Math Dr. B coming live right at you with a video tutorial. Or it may not be live, but it doesn't matter. Just rewind, check it out. Hey, today we are going to jump into a stream of numbers and letters. So I need to forewarn you, don't let your brain overload. Let's enjoy this and kind of relax and learn something called Cramer's rule. Before we go there though, I want to talk about what you might have been doing before, and that's solving a system of equations. Here's a typical test question you might get in an advanced algebra course. Solve for x, y, and z. That's three unknowns. If you have three unknowns, you need three independent pieces of information, three equations to solve for three unknowns. Now, if we look at this, notice that the first equation on top has the three unknowns. But the second equation seems to be missing a y. There's no y variable. The third equation has no z variable. That may be a throw-off to you. You're like, oh, how do I handle this? Well, it turns out that actually makes the calculations easier. So enjoy some of those blank spots. First thing you need to do is you do need to line these up. And I have it right here. So I relined it up where x's line up with x's and y's line up with y's. Notice that second equation, I put in a 0y there as a placeholder to let you know that there's no y's in that equation. Likewise, on the third equation, there's no z, so I put a 0z. Many students out there typically are wondering, should I put a 0 there or a 1 there? The 1 usually is an understood number. In this case, if I had put 1y or 1z, that would have meant it was actually there, but it's not. So the 0 is the correct coefficient to put into this formula or the equation. Now, with solving for systems of equations, the most important thing when you're doing it the hard way is do critical thinking. Look to see if there's any things that can cancel out. Some of you have learned this thing called the Elimination Method for a system of equations. Some of you have heard it called the addition method. But basically, you usually try to add equations to get a variable to cancel out. In this case, do you see anything that seems to be like low-lying fruit or something that might fall out of the sky for you? Absolutely. Positive 8z and a negative 8z. If you add those together, it's gone to 0. It goes away. Well, look how magical equation 1 and equation 2 are. Turns out the x's will also cancel. So literally, if you added this first equation to the second equation, the only thing left standing would be 5y plus 0y is 5y. 10 plus 0 is 10. So you'd end up with 5y equals 10. And quickly, you can calculate that y is equal to 2. And that would be awesome. And for critical thinking, you're trying to find patterns and observations. Well, what happens as things get really complex and these things don't fall out of the sky? Thank goodness for Cramer's rule. It's a rule that will allow you to solve for any number of unknowns and equations, as long as they're balanced. You have to have what I call a square matrix, where you have the same number of equations as your unknowns. Well, Cramer's rule literally is best for programming. And if you wonder how your calculator or computer calculates all these unknowns, it's through things like Cramer's rule, which is beautiful to program. The good news for this class and for you likely is you just want to kind of understand how it works. So let's look at the formulas for Cramer's rule. Typically you'll have a formula like this. You'll have a1x, b1y, c1z equals d1. Don't panic with all these numbers and letters. The 1 literally represents equation 1, row 1, or equation 1. The 2, a2x, b2y, c2z equals d2, 2 means equation 2. Now notice it seems like the a's always line up with the x's, the b's always seem to line up with the y's, the c's always line up with the z's, and the d's are the number. Usually that keeps it consistent so you can figure out where things land. It's really a tool to help you understand location. Well, if you take the formula and you take the actual equations given to you to solve for the unknowns, what do you think the top left is? Top left is a1. So what do you think this negative 2 is? a1. So once you can identify what each of these coefficients or each of these numbers means, you can plug them into formulas. Speaking of formula, here's the first formula for a determinant. They call it D, for determinant, but this big determinant here has A1, B1, C1. Where do those come from? Well, they come from the formula, but they represent actual numbers from equations that you could come up with science or technology or engineering to come up with these equations. Well, you plug in these 9 numbers. Like I said, -2 is the A1. Plug in the 9 numbers. Now you have a 3 by 3 determinant that you need to solve. Okay, yeah, I apologize. Yet another formula to solve for a 3 by 3 determinant. So here's the formula I've written on the board for a 3 by 3 determinant. Now I want to warn you. You're going to see a lot of different formulas, and there's several ways to solve a 3 by 3 determinant. I'm going to show you one way. I encourage you to figure out one that works for you. This one could be the one. But you look at it, we call this A1, B1, C1. Here's where it's frustrating, I need to share with you. This formula and the formula over here are different formulas for different things, even though the numbers may overlap a lot. So don't panic, I just want you to separate this. This says a C1. I would encourage you to think of it as the number that's in the top right. So let's look at this 3 by 3 determinant. What number is in the top right? Yes, positive 8. That would represent my C1, the top right. That would represent this number in the formula. Good. That's huge. So now you have this 3 by 3 determinant. Why would I want to solve this beast? Well, it turns out if you solve two determinants, you can actually use a systematic way to solve for x, for your system of equations. And this determinant D happens to be the denominator for 3 equations. Well, let's solve for this determinant D. You find these numbers, you identify their location within this formula. You start plugging them in. The thing that's nice is you take a 3 by 3 determinant and you make it into really 2 by 2 determinants, which are easy to solve. It's just multiplying, cross-multiplying, and subtracting the other way. So let's look at that. Let's do it in real time. You have 8 times this 2 by 2 determinant. How do you solve this? It's 2 times negative 5, right here, minus, notice I changed it to sexy red color here, minus the other way, negative 3 times 0. Love those zeros. It makes the math really work out easy because it just cancels out. So you literally have 2 times negative 5 is negative 10 times 8. You get negative 80. Keep doing the math. Notice I put money green here. This is part of the formula when you're trying to solve a 3 by 3 determinant. That minus sign is actually part of the formula. So you minus what they call C2. Remember I told you C2 is a location. So it's the second row, the last column. So C2 is middle right. What number is middle right? Negative 8. So notice we had negative 8 there. We do the math again. Negative 2 times negative 5, get a positive, is a negative times a negative is positive. Subtract negative 3 times 5, subtract the negative 15, makes it a positive 15. So now you have 8 times 25. Where did that 8 come from? Oh yeah, minus the minus 8 made it positive. 8 times 25 gives you 200. You add these up and you get 120. That one value is actually the determinant of that 3 by 3 determinant. Okay, now that you've solved D, all I need to do now to solve for X is solve another determinant. Well, the math gets similar and repetitious. Be very careful with your signs. What I'm going to do right now is I'm going to solve for Z actually on this next board. So I rewrote the formulas again and have the actual question. We need to solve for a determinant called DZ. DZ is represented by this formula. These letters go exactly with Cramer's formula. Notice that this last column, instead of having C's, now has D's. It has the D1, D2, D3 from this formula. Well, we know the D's were 10, 0, and 2. I plugged them right here. That's how we filled in these numbers. Look at the formula and look for location. Oh, back to a 3 by 3 determinant. Can we handle the heat? Absolutely. We used that same formula we had on the previous board. I'm expanding across this particular column, 10, 0, and 2. Remember 10 was your C1? Wait, let me roll down the board. Top right was C1. This is the formula for solving a 3 by 3 determinant. C1 was top right. What number is top right? 10. So you're using the formula again to solve a 3 by 3 determinant. You have to be very careful with science. You make one mistake, it kills everything. So be very careful. This is like when you're an accountant or a bookkeeper. Yeah, they care if you miss it by a penny. You got to keep doing it until it's perfect. So now I'm solving for this determinant, which we call DZ formula. Solving with these numbers, this 3 by 3 determinant. Notice that anytime a 0 comes in and you're expanding across this column, oh, how beautiful is that? You don't even have to worry about it. You know it goes away. 0 times anything is 0. Well, let's look at this. We expand across 2 right here. We called it C3, or the bottom right. We expand across it, which is a fancy way of saying we get the determinant, the negative 2 times 0 minus 2 times 5. So that's 0 minus 10. What's 2 times a negative 10? A negative 20. What's a negative 100, negative 20? You put those together, you get negative 120. You just solved another 3 by 3 determinant. Now here's the nice part. You have d subscript z is negative 120. Well, z just happens to be the actual z variable that you're looking for is simply a dz determinant divided by the d determinant. Negative 120 divided by a positive 120, you get negative 1. Now, it may sound strange, but where was the critical thinking? Wasn't it just plug and chug, you follow the formula, you follow it extremely precise? The difficulty was in making sure you didn't screw up the signs, you did all your calculations correctly. But this you can definitely program, this you could do. It's really, I call it a way for you to really work formulas, be very careful, it pushes your brain to be precise. I hope that helped you, just so you could check your answer. Turns out the answers to this particular one, I wrote on the board. If you want to practice it, you get x equals negative 4, y equals positive 2, and z equals negative 1. Okay, that's an example of Cramer's rule and systems of equations. My best to you, don't give up, be strong. This is the Bridge for Math coming at you, Dr. B. Take care.